Hi everyone. Today we're going to study initial value problems. Let us do some introduction first. We're going to solve differential equations. First, let us define differential equations. A differential equation is an equation that relates an unknown function and one or more of its derivatives. The equation dy over dx equals f of x is a simple example of a differential equation. Solving this equation means finding a function y with a derivative f. Thus, the solution is y equals the integral of f of x dx. Later, we will have an answer, and that is capital F of x plus c. This is the general solution. Let's see this example. Solve the differential equation dy over dx equals 6x squared. Let us treat the dy over dx as a common fraction. Let us cross multiply dx to the right side. So we have now dy equals 6x squared dx. And then we will take the integral of both sides. We will have now the integral of dy equals the integral of 6x squared dx. The left side here is simplified into y. This is equal to the integral of the right side. Now let us use our formula of integral to evaluate the right side. So we have now y equals 6 times x cubed over 3. We use the power rule of integral to evaluate x squared. We can cancel the 6 and the 3. So we have now our answer to be y equals 2x cubed plus c. This is now what we call the general solution of the differential equation dy over dx equals 6x squared. Now for the initial value problems, here now is the case. Sometimes we are interested in determining whether a particular solution curve passes through a certain point x sub 0, y sub 0. That is, we are given this notation: y of x sub 0 equals y sub 0. The problem of finding a function y that satisfies a differential equation dy over dx equals f of x with the additional condition y of x sub 0 equals y sub 0 is an example of an initial value problem. This condition here is what we call initial condition. A while ago, we solved this differential equation and we found that the solution is y equals 2x cubed plus c. Now, let us add the initial condition y of 1 equals 5. In this case, we're going to solve for c for this equation. We will do that by substituting the initial condition values. Take note that this notation means there is a point that corresponds to 1, 5. The x value is the 1 and the y value is 5. Let us now substitute these values in this equation. So we have now the y becomes 5 equals 2 times the x cubed now becomes 1 cube. Then plus c. The 1 cube here is simply 1, and 1 times 2 is 2. So we have this resulting equation. Solving now for c, we transpose 2 to the left side, it becomes minus. So we have 5 minus 2 equals c, and the value of c equals positive 3. Now let us substitute the value of c to the general solution. So we have now this y equals 2x cubed plus the c here becomes 3. This is now our final answer. Example 2. Solve the initial value problem dy over dx equals sine x, and this initial condition y of 0 equals 5. For our solution, we can have the shortcut of y equals the integral of this function sine x, then dx. Solving for the integral, we have now y equals negative cosine x plus c. This is now the general solution. Next step is to find the value of c. Let us substitute the initial value condition. This y of 0 equals 5, which means the point is 0, 5. The x value is 0, while the y value is 5. Let us substitute now in this equation here. So we have 5 for the y equals negative cosine x becomes negative cosine 0, then plus c. The value of cosine 0 is 1, so we have here minus 1. And this negative 1, we will transpose to the left side, it becomes positive. 5 plus 1 equals 6, so the value of c equals 6. Let us substitute the value of c to this general solution. So we have now y equals negative cosine x plus 6. This is now the final answer. I hope you learned something from this video. See you again next time.